All right, here we are doing an example where we are going to be solving a trig equation, but instead of finding a finite or a limited number of solutions on an interval between two given end values, normally it would be 0 and 2 pi. Lately, we were even doing including 0 and excluding 2 pi. We are finding all possible radian values. So it really does start off the same way as the specific finite number of solutions, even though this is more general and it's actually called a general solution. I like to do this second. I like to do this after we do the answers between 0 and 2 pi. Okay, so from here, we're going to start this off the way you would start solving any equation, trying to get the variable alone. So you can shout out anyone who's here now and tell me what to do first if you'd like.
Subtract 2sin𝜃+1 from both sides.
Sure. Well, I would just actually subtract the 2 sine theta, and I would do what maybe next after that, Victoria?
Then I would add the 1 to the other side, so it would equal 2 sine theta equals 2.
Oh, maybe, so I'm not sure, Zareen, what you said now that I'm thinking about it. You might have kind of said that, but the way I heard it, I heard you say subtract 2 sine theta plus 1 from both sides, as if like you wanted to bring this all here, but you meant it as a quantity. I'm not sure. I might have misinterpreted it. Maybe you meant the same thing that Victoria just said. All good.
Yeah, I meant just subtract the entire side and make it equal to 0.
Oh, yeah. So getting it equal to 0 is a good practice for sure. But when you already have everything as first degree, the way a factor would look, we don't need to get it equal to 0 because that's when you're allowed to just solve. So whenever we factor, it's usually because it was to the second power, third power, fourth power, and so on. That's when we want to get it equal to 0 first. Since we don't have anything other than a power of 1, which invisible 1 here where the 2's would go, we don't need to. But if you default to that, that's, of all things, like that's probably the safest thing to default to. All right, but I'm looking at it this way where we're subtracting 2 sine theta from both sides. Here it's gone. Here we're left with 2 sine theta equals the minus 1 and the plus 1 are gone. Again, this is when we can say cancel. And then 1 plus 1 is 2. All right. Anybody want to go for it? KF, you want to tell me what to do next?
Divide by 2 to isolate the sine theta.
Beautiful. All right. So we have sine theta equals, now this we don't call cancel. Anybody want to tell me what we do call this? Bianca, you want to say?
Isn't that just simplify?
Simplify or reduce, yes. Divide, not cancel. I will drill that into our heads, whatever it takes, okay? All good. Now, from here, not so bad. We can easy peasy solve. So you ask yourself the sine of what angle or angles between, start at 0 to 2 pi, between 0 and 2 pi. So the sine of mystery, this is a big question mark, equals 1. What angle or angles? Give us the sine or y value of that ordered pair in the circle, on the unit circle, equal to 1. So can someone tell me, do we have 1 or 2 answers, since that's the common thing over here? Do we get 1 answer for this, or do we get 2 answers for this to start? To start, not like when I'm looking for all, because all is going to be obviously a lot more. But on the unit circle between 0 and 2 pi, 1 answer where sine equals 1, or 2 answers where sine equals 1. What do we know? What do we know? I got 3 hands up that were already trying examples before. Go ahead, Danny.
Would it be 1?
Good, 1 answer. There's only 1 answer. And who can tell me what that angle is between 0 and 2 pi? What is that angle? What is that angle going to be? Somebody, go ahead. Chris.
It's pi over 2 or 90 degrees.
Beautiful. Pi over 2. Since it says radians, we'll leave it like that. If If they don't specify, really you could do whatever you want, but you should probably default to radians. Radians is sort of like no units. So if they don't specify a unit, it's probably radians. Now, that's the beginning of our infinite number of solutions here. Okay, there's going to be an infinite number, all possible radian values. On the circle, pi over 2 is up over here. I could get there like that, and it's pi over 2. However, if I went around like that, that's also good. If I went this way, still good. If I went around like this, also good. So how do I write my general solution to answer this question, where it's basically including all answers? So who remembers how to write out the general solution? Want to get it rolling? Go ahead, Carolina. What would we write?
Wouldn't it be like pi over 2, like comma infinity?
Well, that would be if you were using interval notation. It would be saying like everything from pi over 2, starting at pi over 2, and then until infinity. However, let me like reword a little bit here because I think this is something we forget. When you solve an equation, remember, it's not an identity. A trig identity also has an equal sign and trig on both sides. However, we change one side until it equals the other because they are equal. And that means if you were to try to solve an identity by accident, you would end up just everything would cancel out and clear out. And you would get like 2 equals 2, 0 equals 0, 5 equals 5, some true statement. Because any angle could plug into that and work. Whereas when you're solving an equation, you're looking for which angles do make this work. Now, when you said 0 to infinity, you're saying every angle from pi, not 0 to infinity, I'm sorry, pi over 2. Every angle from pi over 2 onward will plug in and make this true. But that's not exactly it. So every angle something will make this equation true. Pi over 2 lands here. Who could fix a little from the idea that we got started with there? How about Alex R?
I think I know some of it. I don't know all of it.
That's
but
okay.
That's the starting. I think it's plus 2 pi, and I think there's like a k in there somewhere.
Yeah, I usually used N, but you guys will always use the first letter you saw. So that worksheet had K. I don't know. I just always use N. But
And then sometimes there's like that like fancy z thing.
yes, the fancy Z thing. So this is saying to add 2 pi, which is a full revolution, N or K or your favorite letter, I don't care, which is going to stand in as like a constant representing a certain thing. And now she mentions this fancy Z thing. The fancy Z thing is this guy right over here. That stands for the set of integers. And in front of it, we had this, where N is an element in the set of integers. And what are integers? Who could tell me what an integer is? What the heckers? Go ahead, Chris. You want to say what an integer is?
Yeah, they're whole numbers, so it's not 1 1/2. It's 1, 2, 3, etc.
Okay, so it's not 1/2. I started writing 1/2 because you said it on impulse. Sorry. 1, 2, 3. Okay, whole numbers, but it also includes, I kind of started writing it, 0. And remember, we could go counter standard. So clockwise, we could go clockwise as well, which means that we wouldn't add 2 pi to get there. We would subtract it. So what else do integers have to include? What else?
Negative numbers.
Yes, they have to include the negatives. So I'm going to go over here, -2, -3, ... the ellipses. And I can kind of go over here. I'm going to draw that Z with the double bar in the middle. I'm going to put a colon. I'm going to use set notation, which is that curly bracket like that. So the set of integers, colon, I'm describing it with the set notation. You need the ... -3, -2, -1, 0, 1, 2, 3, ... So that's just saying that we can start at pi over 2. That's where we start. And you could add 2 pi once, or twice, or 3 times, or 4, or 5, blah, 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 forever. Or we could start at pi over 2, and we could subtract 2 pi once, or twice, or 3 times, yada, yada, yada. Or 0 times, and then we would just get pi over 2. So that just gets us all of our answers. So you guys all had the puzzle pieces. We kind of pieced it together. So this is going to be where we kind of head to next, but we want to make sure we cover a few different scenarios first with simple equations, with using identities to sub things in and out. We want to make sure we can do quadratic type equations. We want to make sure we could do quadratic types that involve Pythagorean identity. And we want to make sure we can do the type where you turn it into a quadratic type. So those are the first 6 examples. Once we do those, then we could kind of transition into general solutions. And then we're going to use our general solutions to do what we spoke about in the transition lesson, where we'll deal with multiple angles. And that has to do with the horizontal stretches, compressions, and translations, shifting left and right, or stretching or compressing horizontally. If you don't know how to write a general solution like this, it's very hard to find all of the answers when you compress a function. So it's all in an order for a reason. So if you understand this, if you're watching this on the YouTube playlist, then put a thumbs up. But if you don't and you want more like this and you're confused, put a thumbs down on it. And that just helps me track, okay? But I hope you were able to follow this.